here's an amplifier that I had found online and was simulating. So I've just put it in a document format so I can edit and point out things that you could see in online circuits. Okay, so the first thing that you need to notice is that it says you need to use a 9-volt battery, but it hasn't specified a battery anywhere. So the ground is in the bottom. Usually we put the supply in the top, so this is actually at least drawn the right way. So what they mean is that you need to put a 9-volt supply here. And then you'll have your signal source and you have an AC source. So here they're using a realistic amplifier, so you have both a minus and a plus. That's the minus, and then this is the plus. The plus is just setting up a bias. So it's setting up a 10k, a supply by 2, so this should be around 4.5 volts. Remember, the capacitor doesn't matter. So this node should be at 4.5 volts. And it should stay there. There's no connection there. So it's just coming from the supply, one 10k, another k, and so this is a R by 2. I mean, there are two resistors, so it's a V by 2, which is 4.5 volts. This capacitor only filters out any, if you have some noise in the supply or something like that, that should get filtered out by this capacitor. So it's just supposed to give you a DC. At the other side, then most mics need a resistor to bias, so that's what this resistor is doing. It's just a bias for this mic. When you connect a voltage source, it will probably not make too much of a difference for you. And this blocks AC. This capacitor is actually blocking AC, so it takes your signals and then it's passing it through the 1k resistor. So the current comes here, hits an annullator, and passes through the output. So because this is a 1 kilo ohm and this is a variable resistor, so if it was set to 100k, you're getting a gain of 100. And then this is the output capacitor, which blocks off the DC and just takes the AC and transfers it to the next stage that may be there. So let's see what are the changes we would need, or basically what is the circuit that we would need to do. The first thing is that there is actually a positive and negative input. You have to connect to those pads. Okay, 1 second. And this is not the kind of amplifier we want to use. We want to use the universal amplifier. So this is just setting up a DC voltage, so that comes here. The other end is the 1 kilo ohm resistor. I'm just going to make it a little more obvious. Okay, so now the input AC just goes in and it will go through the 100k resistor. This needs to be connected to the output, and this will have AC and DC, and okay, if you take it after the capacitor, it should block off the DC and you should only get an AC signal. So the first thing is you need a supply, and that's what they're trying to indicate here. There should be a supply there. can even put the supply this side, it's fine. You always have to put a ground. The ground is there. It also G. Okay. So this is a resistor to bias. It should not make a difference, even if whether it's there or not. This voltage we have to set up to 9 volts, as they have said. Okay, and now you need to feed supply to the, sorry, so this is at ground, and this is the supply. I would move it a little away so it's, well, F8 is drag. If you didn't want to move it and you just wanted to drag it, okay. And F7 is actually to move it. Okay, so now we are ready to simulate. Oh, we have to check what the input was. This we have to be careful about. So we'll see what it is. So this is the voltage, so that's the input. Input is okay. The amplitude is 2 volt amplitude, and the frequency is extremely low. Okay, first let's just start with the supply. So this should be 9 volts, there should be ground, that's fine. And this voltage we thought should be half of the supply, so that's 4.5 volts. 4.5 volts, so that's fine. Okay, so the biasing is set up fine. Now let's look at the input signal. So usually if you are amplifying by a factor of 100 and you have only 10 volts or 9 volts, you wouldn't expect the input to be so large. So I'm going to make it maybe 20 millivolts, and the frequency we can't hear below 20 hertz, so I will at least make it 100 hertz, and the time delay is not necessary, it's fine. So 20 millivolt at 20 kilohertz, at 20 hertz. It's a small signal here. I made a mistake. Sorry. Oh, I didn't simulate again, so. So another reason it's flashing so much is the time that we are simulating for. We are simulating for 10 seconds. Now 100 hertz is 100 periods in 1 second. Even if you simulate it for a couple of seconds, you should be okay. And you don't need all that, it's fine. Start, that's fine. Down, almost there. 2 seconds, right. So the input signal is that small, it's really tiny. So let's see if this is at virtual ground, it is at virtual ground, and let's see the output. Yeah, so the output is, so let's look at the input again, let's zoom out a bit, zoom to fit, that was the input, that's the output, and there you see the amplification. Input, you double click it, you get 2 cursors, you can see the voltage peak to peak. So you see the peak to peak voltage is 38 millivolts, around 40 millivolts. And now if we look at the output, one down, vertical it's 2 volts. Okay, so the first question is, okay, great, there's a lot of gain. It was 20 millivolt input, that's one side, so 40 millivolt input, peak to peak. This is referred to as peak to peak. The signal will go 20 millivolt high, and well, I should just plot the signal I'm talking about. There, 20 millivolt high and 20 millivolt low. So if I talk about peak to peak, it's 40 millivolts. But the output is 2 volts. So the output should have been 4 volts. If the gain was 1k, 100k. So this is where what is the impedance of the capacitor plays a role. There is an impedance even of the capacitor. It's not a short because the frequency is not high enough. But if we had, say, 10 kilohertz, and of course we shouldn't run it for so long, 10 kilohertz, even 2 milliseconds should do. Okay, so then the amplitude is the same, frequency is what has changed. Now let's look at the output. If you click it twice, it only plots the output and removes everything else. So 1, okay, fine. So this is around 4 volts. So now the drop across the capacitor has become extremely small. Most of the drop is across the 1k resistor, and that's what is getting amplified 100 times with the 100k resistor.